Hello and welcome back. Today we are going to take a look at the second qualifier case for the 2025 Microsoft Excel World Championship, once again called the number one fan, as all these qualifying cases have been called. Now the difference between this case and the one that we saw in the last video is that this case was played at 5 p.m. London time, which is a much more suitable time for the rest of the world that logged on and competed and qualified for the main event. The basis of the case is the same. In fact, the story is the same as the video that we just saw. The layout is the same. The main difference is that because this is a separate case, we have different tasks, different sections. So once again, all of these sections are based off of a section from a case over the past 5 years. So for example, section 1 is from Share the Ride, which is from the 2021 FMWC Open. Section 2 is from Laundry Time, which was back in 2023. Section 3 is from Super Grandmaster, which was from back in 2022. Section 4 is from We're Not in Kansas Anymore, the first battle of this year's competition. And then Section 5 is from Lana Goes Ice Skating, which was on the game day competition from last year's Microsoft Excel World Championship. So, I won't read the story like I mentioned here, because if you want to see the story, you could check out my previous video. This case has 1 hour to solve. So I'm going to see if I can solve this case within 1 hour. Come along with me as we go ahead and explore. Here we go. Section 1. A ride-sharing company has just entered the market of a fictional city, Fun City. They need your help to analyze the road network and develop a ride planning and traffic forecasting app. You are provided with a map of Fun City, and in the S1 Fun City map tab, the map is populated with vehicles and buildings. This map brings back memories. I wouldn't say good memories, just memories. Task: which unit is located on each of the following cells on the Fun City map? Provide your answer as the unit's name. Now, there's a couple of ways that I could go this. One of my favorite ways to do this is to flatten out the map. So you see I do row, column, address, but because I'm only going to use this map once and only for this one purpose, just check the notice. Yeah. I'm going to go ahead and just do the indirect function, but there's one extra step I'm going to do after I even get the answer. So you'll see it here. So we're going to do indirect S1 Fun City map and that location. So that's going to give me the icon. Yep. I'm going to look up that icon into this table, returning from the unit name. Of course they're merged cells. Why wouldn't they be merged cells? Right. For some reason this did not write in the position I expected. That should be how that formula goes. I should get residential house. Yes, I'm going to go ahead and paste them in the rest of these. Yes, and then I'm going to paste values, because indirect will continue to recalculate just like data tables will. I don't want that messing up my speed. Alright, section 2. You have delayed putting your laundry away for too long, and now all your clean clothes are stacked in a giant pile, and that's all you have to wear. The only type of clothing you wear are socks, shoes, underwear, pants, t-shirts, and hoodies. Thankfully, you also have access to a laundry detecting tool, which can give you the list of all your clothes in the laundry pile. The laundry detecting tool gives an output based on one letter as noted in the table on the right. Okay, so that's this table here. Also, you are provided with the weight of each item in grams. Oh, this was interesting. That was not in the original case. Task: what is the total weight in grams of each of the laundry piles listed below? Oh, okay. That I could do with a single formula. So what I'm going to do first is I'm going to put all the letters in its own individual cell. So regex extract will do that. I'm going to go based off of that. The pattern is any capital letter, return all matches. There we go. So that gives me all the letters in its one individual cell. Now I can XLOOKUP all of that into this table output, return the weight in grams. There we go. We got all the weights. Let's sum all that together, and that should give me the same answer, 29,100. Yes. Let's go ahead and put that into this cell here, and there we go. Pretty easy to solve. Alright, section 3 from Super Grandmaster. You are presented with a 100 by 100 cell chessboard that is filled with your opponent's chess pieces. C-Tab S3 Super Grandmaster. Ooh, nice big board. Okay. Each of these pieces is assigned a point value based on its relative strength in text terms. See the table to the right. Your goal is to model how many of these pieces' points are located with a certain region on the board. You don't need to know chess rules to solve this case, only the point values for the pieces. There are 4 different types of regions: row, column, rectangle, and circle. For the rectangles, you're given 2 coordinates, the top left and the top bottom right cell. Rows and columns are just a special set of rectangles. Circle regions include all the cells that are within X number of cells from the center going horizontally, vertically. X is the radius in this case. Task: what is the point value of the pieces that are located within each region? All right, so I will admit I saw a bit of the live stream because I just had to watch Dim solve the whole case in 30 minutes. I did see his approach. I'm going to take a similar approach. So because rows and columns are just a special set of rectangles, I'm going to use the same formula to knock out these 2 types, and then we'll take a look at the circles part here a little bit later. So rectangles, rows, and columns, they give us all starting and ending cells. So what I'm going to do over here is I'm going to do another indirect function. So this is S3 Super Grand Master. That's the name of the sheet. And we're going to start from A2 and go to B5. So that should give me the name of all the ranges. There we go. And then what I can do with that is I can XLOOKUP those results from the piece here, return the points there. Oh, if I get an error, all right, so I'm getting errors, so let's do errors are 0. Yes, okay. Sum all of those together, we get 5, which is what we get for this part here. Now this code will work for rectangles, rows, and columns. I'm going to use that code and paste it all the way down there. I'm going to copy paste values because once again, I don't want to recalculating all the time. It's a volatile function. But I need to figure out these circles, or what really is the case, diamonds. See, it looks like a diamond, doesn't it? And for this, what I'm going to do is I am going to flatten. Let's start by flattening this out. So I'm going to call this, let's say, section 3 map there. I didn't need capital S, but oh well, it's a capital S. All right, let's flatten it out over here. Row, call, address, val. Okay, so tuple map, section 3 map, row, tuple map, section 3 map. Oops. I gotta do it again. Fine. Map, section 3 map, column. It's interesting why that takes a long time to type. All right, address. For this row, this column with 4, so that gives me relative addresses. And then the value is tuple S3 map. And then I'm going to add this blank so that blanks are actually blanks. There we go. Okay, cool. And I'm going to add points because every one of these is points, right? So I'm going to XLOOKUP this column. Let's go back to the table over here. Boom. And boom right there. Okay, so that's going to give me points. Oh, I need to add 0, right? Because some of these pieces. There we go. So we have all the pieces. And then what I'm going to do is I'm going to work with example 3b first. All right, so example 3b, start distance. So example 3b. So the start is ranges here, and so that's not going to work. Okay, so I'm going to work with the start there, so it's I. I'm going to remember that the distance is k, or the radius is k. Just type radius here. Let me delete this column. This is going to be k. Right, so the radius is there. So what I'm going to do here is I'm going to determine the row and column number of that center point. So for the row, because the row number is already in there, I'm going to use regex. So that's going to bring out the whatever numbers in there. So that's row 5. And then the column, I'm going to use indirect for the column because I mean, there is a way to do it formulaically. It's much longer. So I'm going to do column indirect E5. Okay. So, and then back into my flat map table, I'm going to add a distance. So, let me just think here. Because the diagonals are not considered, right? I don't think it's specifically said. Yeah, okay, going horizontally and vertically. So diagonals are not considered. So the distance is going to be simply, let's see, so sum of the absolute difference of row minus that row there, and the absolute distance of column minus that column there. Oh, maybe I just shouldn't use sum, because that's going to give me the total sum. I don't want the total sum. I want it to go row by row. There we go. All right, now we have distances. So, let me just check here. So let me filter these 5 columns where this column is less than or equal to 3. See what we get. Okay, so we got those columns, and those are the these are the points values here. So I get a total point value of 32, and yes, 32 is what I'm looking for. Excellent. So now I'm going to change this up a bit. So I'm going to do sum ifs. I'm going to sum the points column where the distance column is less than or equal to the radius there. All right, we get 32. Good. I'll put it over a cell, and then this will let me run my data table. There's only 5. Ooh, some big numbers here. Alright, let's put these in there, and they all check out. Excellent. Alright, so I think 1 indirect should be fine. Hopefully, we'll see. Section 4. We're not in Kansas anymore. Dorothy, a girl from Kansas, has been swept up in a tornado and landed in a place called Oz. She will embark on an epic journey to return home via the Yellow Brick Road in Emerald City. There are a total of 336 bricks on the Yellow Brick Road, each having a unique number from 1 to 336. Merge cells. Who doesn't love merge cells? Each brick is represented by a merge cell that has the size of 2 Excel cells. The numbers are assigned in random order. Task. For each given brick, what is the sum of the 2 adjacent bricks located to the left and to the right of it? Okay. Right. So, because all the numbers are unique, I'm going to flat map this again. So I'm going to call this is section 4 map. And once again, let's do row, column, address, value. 2 column map, section 4 map, and get the row out of that. 2 column map, section 4 map, and we're going to get the column number out of this. Address is going to be the row, column, relative reference, and the value is going to be, and I need to check if this is going to work with merge cells, but hopefully it should be 2 call section 4 map, and that should do it. Now, one thing I'm thinking of is I could add this extra null bit here at the end to get rid of my zeros, but you see what that does is that's going to change my numbers to text. Because I'm only going to deal with numbers, I don't think I want to do that. So I'm just going to leave those as zeros. But that also tells me that everything is working out right. So like A1 and B1, we're only going to get the cell from A1, which is what I'm looking for. So let's bring the case information. So this is example 4. From the example, we're going to get brick number. Okay. Whoops. Brick number. So let's go ahead and I guess it's in column G. I hope it's in column G. It is in column G. Okay, so row, column. So this, what I can do is I'm going to look up the brick number into this volume because they're all unique, right? I'm going to return the row and column numbers there. So that's going to be a row 1, column 3. So that's going to be what? 44 right there in C1. Excellent. Okay, so now the 2 bricks that I want to the left and to the right. So let's do left brick is going to be Let's see. So should be in the same row. And the column should be that column minus 2 because we're working with merged cells. And then brick number is going to be S4 and P. Working with row 1, column 1, 169. Okay. I'm going to do the same thing with right brick. So that's going to be row 1. Column number is going to be this plus 2. And I get 312. So then my total value is going to be 169 plus 312. What do I get? 481. What's the answer? 481. Excellent. Okay. Let's go ahead and run through the data. Whoops, that data table goes there. Going to replace the example number with the game numbers. And let's just put that in. Oh, that's not good. That's not good. What did I do wrong here? All right, let's check 62. 46 and 16. How did... Okay, yeah, 16 and 18. Oh, how did that get so... No. Row number should stay the same. How did I mess that up so badly? Alright. 16, 22. So 16, 18, 16, 22. Okay, let's try that again. There we go. Okay. You know what? I did that in practice as well. Can't believe I made that mistake again. Alright, section 5. Very hard. Lana Banana is a monkey who loves bananas. She has heard that a nearby frozen lake in tab S5. Oh, I remember this lake. Has been covered with snowmen, crystals, and more importantly, bananas, so she's gone to her ice skates. Has significantly improved her ice skating skills. She can now change her skating direction. The ice crystals will speed Lana up, and the snowman will slow her down. For each game, you're given Lana's starting cell as well as 7 moves. Each move consists of several turns that Lana travels in the same direction. For example, any 5 means Lana will travel 5 turns in the northeast direction. The number of cells traveled will be based on her speed and the lake boundaries. Note that we give you the number of turns, not the number of cells traveled. Right. Lana starts by skating 1 square per turn. Oh, speed. Speed equals 1. When she skates over 1 or more ice crystals during a turn, starting from the next turn, she will gain more speed and move 1 or more extra squares per turn, depending on how many ice crystals she skated over. When she skates over 1 or more snowmen during a turn, starting from the next turn, she will lose speed and move 1 or more squares less per turn, depending on how many snowmen she skated over. If her speed drops to 0, the move is over. She starts the next move at a speed of 1. If Lana leaves the lake or travels on an island, the move ends and she stays in the last cell with ice. As Lana skates over bananas, ice crystals, and snowmen, they disappear. If Lana skates over the same cell again, there is no effect. Oh, I love that part of the case. And by love, I mean hate. At the beginning of each move, Lana's speed is 1. See example 5 for a detailed explanation. Task: on which cell will Lana end up after the 7 moves? Oh, okay. Once again, a nice, extremely long set of directions. I think these directions are even longer than the morning set. Let's go ahead. So let's call this S5. Let's bring the frozen lake over next to it so I don't tab over so much. Let's get all of these instructions in there. And this will be my data table runner. So let's look at that. And BB, return G. Oh, we're not dealing with numbers. We're dealing with a combination. So these are going to be read as string. So we're going to add that blank in there. Oh, come on, man. Learn how to keyboard. I need to do that practice keyboard thing. There we go. Okay, so these are the moves. Let me... What does NW10 mean? Lana moves in cell northwest direction for the next 10 turns. Okay, so we have moves and we have turns. Alright, let me extract the direction and turns, let's say? Yeah, that sounds right. So, we're going to get the letters out of this. And this one we're going to get the numbers out of this. And then we're going to multiply the numbers by 1. Alright, so let's center these because it's going to bug me. I'm going to mix it up. Alright. So, what we need to do is... I'm gonna do this in a nice long table. So sequence. This is gonna just let me just do sequence of sum of all of the terms. So that's gonna tell me how many rows I'm dealing with. 44 in this example. Okay, and then so move right. So gonna work? I don't know if this is gonna work. I want to try H stack. No, I don't want to H stack those. I want to V stack those. I'm gonna stack these vertically. So I'm gonna put the move number on top of the turn number. So that's gonna give me those in 2 columns or 2 rows. I'm gonna do by call that. I have no idea if this is gonna work. This is probably not gonna work. Sequence. Oh, I gotta put that in lambda. Lambda. Just A, I guess. I don't know if I can do A and B. I'm gonna just do A. Lambda A. Sequence rows. Index A2. Starting with index A1. Repeating 0 times. Is that gonna work? No. Okay. Would have been nice, you know, Excel. All right. Because basically what I want to do is I want to put 1 10 times, followed by 2 4 times, followed by 3 4 times. And I bet the only way I'm going to be able to do that is the same way I did it in the previous case, where I'm just going to do it over here. So 7 there. All right, so let's do sequence of, take that, find the number of turns, and that should be, and now I'm gonna have to deal with columns. I'm gonna make a note of that. So that's gonna be in columns, starting with once, the step of 0. Okay, yeah, now if I then, it's going to go by 10. What's that? Okay, so that does, whoa, oh, take 3s. Okay, so that does when I, why is that longer? That's, what? 44, how many do I have here? I have 51 there. Oh, okay. Because that is not. There we go. That should match then. Yes. But that range may increase in size. So what's the largest number I have here? Just see. I think 10 is the largest number I have. Well then, fine. Alright, so 10 is the largest number I have in the example. What's the largest number I have there? Why you get... Oh, right. I forgot that part. Alright, largest number is 10. Okay, so that range that I did there, that will work. That I don't have to worry about that expanding. Okay. Turn. Just basically going to count every time that number appears. So this should give me a turn of 1 to 10, and then 1 to 4. Yes, okay. And then let's do starting cell. So we're going to start there, and let's do row and number values. So that's the row. That should be column is what I meant. Column is column. Okay, so that's row 8, column 34. Okay, and then we're going to do, okay, so let's do direction. So we're going to see the direction from move 1. So that's going to be northwest. Right, okay. And then delta row, delta column is, all right, now you might have saw this in my last video. I'm going to do a nice little trick that works well with the cardinal directions. So row, south means the row is increasing, north means the row is decreasing. So is number search south in there, so that's going to give me a true or false, minus is number search n in that cell as well. That's going to give me a true or false. So south is true, it's going to be 1 minus 0. It's going to be positive, that means the row is increasing. In this case, it's an n, which is going to be false minus true, 0 minus 1. That's going to give me a negative 1, which means the row number is decreasing. That's what I'm looking for. All right, and I'm going to do the same thing here. So east means the column is increasing, west means the column is decreasing. All right, so northwest means we should be going up 1 row, left 1 row. Yes, that's what I want. All right. Now, oh, I need the speed. I need to get the speed in there. Let me put the speed. Now, when I think it said here, let me just check. At the beginning of each move, her speed is set to 1. Yes. So what I'm going to do is, if this is the first turn, we're going to set to 1, and I'll figure out what to do later for the rest. So I think I have everything I need to figure out which cells she traveled to. So I'm going to do, I remember when I did this case, the speed went relatively high. I think it went higher than 5, but no higher than 10. So I'm just going to figure out 10 cells that she could have traveled to. Okay. Now, when I practiced this formula was interestingly quite good. Basically what I want to do is I want to count all the cells that she would have traveled to. So that would be a nice long address function. The row number is, we're going to start with 8 plus sequence. The number of columns is going to be the speed. That tells us how many cells that she travels to. And she's going to start at the difference in row, and each step is going to be that same difference there. So that gives me the row numbers, and the column numbers I should be able to do the same. So the sequence is the speed. We're going to start with the difference in column, and it's going to increase by the difference in column. Then that is not going to work. Oh, because I forgot to include the column number. Alright, there we go. So from AH8, if we go up to the left, that would be AG7. Yes, that's right. Okay, so we got the cells here. Now let me just check if I change the speed to 5. Alright, so she's going to run all 5 cells. Excellent. And then let's go value. And then I think what I want to do here is I don't want to do a bunch of indirects over there. So let me go ahead and find this map out. So we're going to call this S5 map. Let's go ahead and get my row value, column value, address value, and contents or value. All right, so these are going to be the same 4 formulas you've seen the whole entire time. So to call map S5, whoops, not just S5, I need S5 map, and we're getting the row number there. To call map S5 map. Come on, Ben. We're getting the column number there. Address is going to be that there, and the value is going to be to call S5MP. Now, since we're not dealing with numbers here, I need to find a nice uniform way to do that. Right, we're getting a lot of blanks, but that's because the first row is very blank. Okay, I'm seeing symbols that we're going down there. Excellent. Now, let's go into this value. So, oh wait, I think I just do XLOOKUP this array, although it's only an array of 1. Later it could be a larger array. We're going to look that up into the addresses and return the values. What's that going to give me? Oh, that's going to give me a banana. Guess what? I don't think bananas do anything. No, they don't. All right. So I zoomed out just a little bit. So I love this vision glitch I get sometimes. All right. What I need to do is I need to figure out how many ice crystals and snowmen she found here. So I'm gonna get ice crystals from here. I'm gonna get snowmen also from there. Okay, so we're just gonna do count if this array is one of these two. No ice crystals, no snowmen, so end speed is going to be our starting speed plus ice crystals minus snowmen. Is that about right? I think that's about right. Oh, I'm missing walls. Right, she's going to stop at a wall sometime. Alright, first I need to label the walls, and I'm worried because this does not work well when I'm recording. Oh, it's working well. It's working slow, but it's working well. I can accept slow. Don't tell the clock on the top right corner of the screen. All right. Now, the reason why I had to do this is because the cells were previously blank. And so when I was returning them from the table here, I wouldn't get an actual value. It's going to come back as blank. I'm not going to know if I hit a wall or not. That's not what I want. All right. So now we're going to start at whichever cell we ended with. I'll figure out the walls later. I can't think abstractly or without seeing them. We'll see it here in a minute. So start is going to be taking this array, the last value, speed. All right, so I think speed is the only thing we need. So that we can get in there. Yes, speed. Right. So speed is if the wait. Why is that a number one? I thought I put a formula in there. I guess not. All right. So if it is the first turn, we get 1. Otherwise, we're going to take the end speed from the previous row. Yes. Okay. Do we hit any walls? No. We just hit another banana. All right. Let's keep going now. And I want to see what happens when I hit a wall, because I need to figure out how to code that in. All right. So we hit a wall there. So two things come into mind. Number one, when we hit a wall, we need to start with the cell just before we hit the wall, which I haven't put in here. And then second is items can only be picked up once. I'm going to include that here in a minute. Let me start by handling the wall issue. So, problem is I need to include, so here's what I'm thinking, okay? When I hit a wall, like this here, I need to take the cell just before that one. The problem is I don't have a cell just before this one in this array, because that would be there. Actually, no, you know what? I can have a solution for this. I think I can have a solution for this. Okay, so, if this first one is a wall, take the previous cell. Otherwise, if any of them are walls, then what I want to do is I want to take the cell just before where that wall is. So I'm going to take index of the cell numbers for the right. So for the X match, where the wall is in this array, -1. So I need that cell just before we hit the wall. Okay. Otherwise, if we don't hit a wall at all, then we take the last value in that array. All right, good. Okay, so see, we're hitting walls here. We're hitting walls, right? This actually makes sense. So it did say that when we hit a wall, the turn. Does it say that when we hit a wall, the turn ends? What did it say for wall? This is the point where I want to like control F wall. If her speed drops to 0. If Lana leaves or moves or travels on, the move ends and she stays on last cell with ice. Right. So this is actually showing that because each turn is like, I still want to hit the wall. I still want to hit the wall. I still want. Just imagine a penguin bumping her head into a wall the entire time. That's fine. All right. So, right. So the next thing I need to consider. Okay. So I consider the wall problem. That's good. The next thing I need to consider is the empty cell problem. Right. Okay. So. Here's what I need to do is I need to take any previous cell and mark it blank, except if it's a wall. Except if it's a wall, I can't mark the wall blank. The wall's not going away. Okay. So, first priority. If that's a wall, mark it as a wall. Otherwise, if any of these previous cells will that work? No, I'm going to stick with the actual range here. Right, so we're going to go from L59, that can lock, this column can lock, and if any of those match L6D, then we're going to return blank. Otherwise, we can return what we originally had. That, let's see, do we have any time? Let's see here. So turn 1 she gets banana, turn 2 she gets banana. Why is this not mathing? Why is that not mathing? That's interesting. That's not actually counting, that's, oh, because I didn't lock it. There we go. Okay, now her speed has gone up. So now we're getting 2 cells here. Now we hit a snowman, her speed went down. Okay. Is that what the... Yes, okay. So, move 1 through 5 ends in cell AC3. Yes, it does. So we're hitting AC3. Good. Move 2 speeds reset to 1. That also hits the border of the leg, so we can't actually go anywhere. Turn 3. Move 3. So 84, which is empty. Yeah, 84. Move 3, turn 2, she travels to cell 85, which used to have an ice crystal. That is not showing up here. Okay, good. Why are we getting calc errors? Oh, we're getting a calc error there. Why are we getting a calc error there? That formula doesn't change. Why is that not working anymore? She can't be going off because she'll be hitting a wall before she goes off. Why is that not working? That was working earlier. Yeah, so this is where the first empty array. Oh, it's because her speed is 0 here. Okay. Right. Okay, so if her speed is 0, then just return the start. Otherwise, return all of that. See, there's a lot of debugging that's going on. What was the question? The question was, which cell does she end up in? So she's ending up AB13. Is that the answer? Yes, that is the answer. Okay. Wow, that was fun. Now, the only thing I need to consider is that there may be more moves, because this was not built with dynamic arrays. See, I probably could have done that with a scan function, but no. I'm still not very proficient with the scan function. So let me then just see what is the maximum I would have to go. 53. All right, so just change the small look to go to 53. Okay, and then now this is going to give me some errors. So what I need to do, until it's 44, where does she end? Okay, so yeah, so what I need to do is just figure out where she ends up on 44. So the way to do that is I'm going to X look up 44 in the sequence column. And I'm going to return these 10 cells here. So that's going to give me 10 cells there. Yep. Now I'm going to trim that range. And now sometimes it could be more than one cell, so I'm going to take the last cell. So we get AB13. Alright, let's see how bad I screwed this up. Key number in there, run through the data table. Ooh, I have answers. That's a good sign. Are they the correct answers? Mostly. Alright, let's take a look at number 87 and see what happened with number 87. It's probably something else I didn't consider. Let me delete this data table because that data table is going to just keep running. Alright, so after 26 moves, she ends up on AX60. That's what I've got an NA there. Why do I have an NA there? That's concerning. Oh, okay, yeah, she doesn't end up in AX60. She ends up in AX58 because there's an X there. Okay, so instead I'm going to X lookup. I'm going to do X match. I'm going to use that starting cell, but instead I'm going to do this number plus 1. So that's going to give me where she would start the next whoa, I did that backwards. That would give me where she would start the next move, which is where she's ending the previous move. I'm still getting an A. So we're looking up 27. Oh, not X match, index. That's why I did it backwards, because I actually did it right, but I used the wrong function. Okay, AX58. Let's run through the data table again. And I get a ref error. Okay. So ignoring that ref error, let's see. Do I get the rest of these right? And yes, I got the rest of these right. Now, why did I get a ref error on 82? Let me just see. Oh, I bet it's because it went all the way to the end. I should have gone 54. 54. Let's run this down again. And run that down again. And now I'm going to get an answer for that? No. Oh, because, yeah, I need to now go to 113. Now do I get an answer for 82? Yes, I do. Okay, let me just check that. These are all the right answers. I do believe that they are. Yes. Okay, cool. And let's go back and check the bonuses. Okay. Bonus 1. How many cars are there in Fun City, including trucks, ride-sharing cars, and regular cars? Okay. So let's go ahead and name this S1MP. That's going to be the map. So section 1 map. And let's do count if section 1 map of these items here. We want trucks, ride-sharing cars, and regular cars. So we're just going to sum those first 3 numbers. All right, second bonus. How many t-shirts are there across all the 20 laundry piles in games 21 to 40? Okay, that should be pretty easy. So, length concat. So we're going to take all of the piles together, find the length of those. Minus length, substitute. Combat all those together. We were looking at t-shirts if I remember right. So we're just going to take the T out of that. So the whole text minus the whole text without t-shirts is 194 t-shirts. Good. Bonus C. How many chess pieces in total are on the 100 by 100 board? Okay. So I made that flat map, right? Yes. And Are any of the chess pieces 0 points? I don't think so. No, they'll have a point value. So we're going to count all the point values where they are equal to 0 or greater than 0. So that means that should tell me how many chess pieces there are. Yes. Okay. Bonus D. What is the smallest sum of numbers on a 3-brick sequence that is located in the same row? Ooh, okay. So I remember when we were doing this case, one of the challenges was, of course, the fact that it is merged cells. The bonus on that one looked at triangles. This one's not looking at triangles, thank goodness. So we want a combination of 3 cells. 1, 2, 3, just like that. And I'm going to paste these all the way to the end. But when I get to the end, when I get to the end, there's going to be a point. You see, I get a value error there, and that's because it's counting not 3 bricks. So I actually don't need to worry about that. And I believe that's the same for this one here, but this one can stay. Yes, okay. I'm going to do the same thing for the second row. So 1, 2, 3. And I can leave out the last 2 bricks once again. And now that I have this pattern, I should be able to copy and paste this all the way down. Right, and the question was, what was the largest? What is the smallest? Okay, so we're going to find the minimum of whatever is in this map here. Excellent, 120. All right, bonus E. If you count all the bananas from all the odd rows, count the snowflakes from all the even rows, and then subtract the number of snowmen from all the rows that can be divided by 7 so that the remainder is 0, what is the result? Huh. That sounds like fun. All right. So, I think I can use my flat map for this one. Let's see. Do I want to use my flat map, or do I just... You know what? Let me just use the rows that I have here. So count all the bananas from the odd rows. So what I'm going to do is, if is odd row, then count if these are bananas. Did that work? I think that worked. Yes. Okay. Otherwise, return 0. Alright. Add the count of snowflakes from all the even rows. Okay. So plus if is even row, count how many snowflakes there are. So we're getting a number for most of the rows. Excellent, excellent, excellent. Finally, it's the last bit. Subtract the count of snowmen from all the rows that can be divided by 0 so that the remainder is 0. 7 to the remainder is 0. So gotta count all the snowmen in every 7th row. Okay, subtracting the number. So if mod of row number with a divisor of 7 equals 0, then let's count how many snowmen are in that row. Otherwise, return 0. And I think it's just the sum of all these numbers here. Whoops. 326. Is that the answer for this one? Yes, it is. All right. So there is an example of how to solve the afternoon case. My timing was just about the same. Saved about 4 minutes from what I remember doing in the afternoon case, 4 or 5, or morning case, 4 or 5 minutes. I don't remember exactly. But yeah, I think some people tried to speculate which one was easier, which one was harder. I feel that, I mean, you probably noticed that a lot of these I could just use a single formula for that one, for that one. This one I can't use a single formula because there are 2 different types of really questions in this level. That one I ran through a data table. This one I ran through a massive data table, which, and I had to debug it quite a few times. So overall, once again, another really fun case, really useful for those who are prepping, getting ready for the Microsoft Excel World Championship. I like these qualifier cases because you get a range of challenges. Are these all the challenges that you're going to see in the World Championship? Probably not. You're probably going to get others. I'm going to get others, and I'm not sure what to look for yet. So, if you're in the World Championship, I wish you good luck. If not, I hope you enjoy watching it. Take a look at all the channels that are recording and posting these videos on how to solve these cases. I hope you enjoy them all. If you do give us likes. We really appreciate them. Feel free to subscribe. We appreciate that too. And over the next few weeks, we're going to have a lot of cases coming out. These cases are going to come out fast. Basically, I think we can expect 10 cases over the next 2 weeks, 10 official cases. So these channels are going to be busy pushing out content. Hope that you enjoy them. Take care, and I look forward to seeing you for the next video.
It's the Excel World.